So in this lesson we are going to talk about applications of SOHCAHTOA, and to do that we need to first define what's called an angle of elevation and an angle of depression. So if you look right over here in this diagram, you can see that the angle of elevation and an angle of depression are created by a horizontal line, and then this is what we call a line of sight. So the line of sight is basically what kind of draws your attention and what your eye is looking at. So imagine the horizontal. This is like your neutral, you're looking straight ahead, you're looking parallel to the ground. And you see something above you that catches your eye, and you tilt your head up and you're looking up. That's what creates what's called an angle of elevation. So again, it's an angle created by a horizontal line, think your neutral position, and a line of sight to an object above that horizontal line, for example, angle 1. Now the angle of depression is going to be the opposite. So you're still starting with that horizontal neutral line, right? So that's this dotted line. So now put yourself in the position of this pilot. So you're looking straight ahead at the clouds, that's your neutral. And then you notice the tower coming up in the distance. So then you tilt your head down toward this line of sight. Okay? That angle going down from the horizontal is what we call an angle of depression. So the key thing for your angles of elevation and angles of depression is you must always start with a horizontal line. Okay? And then you're either going to go up or you're going to go down. Now one thing to note is, remember, all your horizontal lines are always parallel. So if we have parallel lines, what kind of relationship does angle 1 and angle 2 have? Well, hopefully we all answered they're alternate interior angles. And when you have parallel lines with alternate interior angles on a transversal, they are congruent. So what's cool is you can always place an angle of depression at an angle of elevation, and that's usually where I see mistakes. So you can always think angle of elevation, even if you're given angle of depression. So again, that's an important thing to note down, because when we do these word problems in the next few examples, a lot of times it's when you're given the angle of depression, I do see people making mistakes. So if you always want to put angle of depression where you say elevation, perfectly fine, because they're always going to be congruent. Okay, so let's take a look at example 1, and the thing about today's work is you need to not only calculate the missing information, but you need to draw a picture to help you do it. So let's take a look at example 1, and we're dealing with this Space Needle. So we have the Space Needle in Seattle casting a 67-meter shadow. The angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. What is the direct distance from the tip of the shadow to the top of the Space Needle? So we want to be able to interpret what the problem is telling us. And here, our Space Needle, we are going to put as this perpendicular length right to the ground. So there's my Space Needle. Alright, so I'm just going to put Space Needle, SN for Space Needle, okay? And then it's casting a shadow, so where it logically makes sense for a shadow? Well, the shadow should be along the ground. So here's my shadow. And my shadow is 67 meters. We have an angle of elevation going from the tip of the shadow to the top of the Space Needle. So that's telling me my line of sight goes from the end of my shadow to the top of the tower, and that angle is 70 degrees. So there is my picture. What we want to do is we want to calculate the direct distance from the tip of the shadow to the top of the needle. That means directly from the tip of the shadow to the top of the needle. What is that? We're looking for that hypotenuse. So there's x. And once we have our picture, then it's just a matter of what are we going to do, sine, cosine, or tangent, because we're dealing with these right angles, right? So what do you think we're going to do to find x using 70 degrees and the 67 meters? Oops. Well, hopefully we have x is the hypotenuse, and 67 is the adjacent, so the correct work is cosine, because we want to do cosine of 70, which is my angle, is adjacent over hypotenuse. And then we can go ahead and cross multiply and solve. Okay, so there's my solution. Make sure we're rounding to the nearest meter, which is the nearest ones place. Remember, it never hurts to have your exact answer, because on your test, I could ask you to do this on the non-calculated portion, so we want to stop with the exact answer, and of course be able to round it. All right, let's do one more example, and then we'll finish the last one in class. So let's take a look at example 2. We've got an ice climber standing at the edge of a crevice, and a crevice is basically like a ridge, a cliff, right? That's 115 feet wide. Our angle of depression is what we want to look at now. So we're looking at an angle of depression, not elevation. From the edge from where she stands to the opposite side is 52 degrees. We want to know how deep is this crevice. So how would we depict this picture? Because we want to be able to create a right triangle out of this so we can do SOHCAHTOA. So if you think about the ice climber, this is this happy little person, hopefully all bundled up for the cold weather, standing at the edge of some cliff. And it doesn't really matter what that crevice looks like, but we do know that from one end to the other, it is 115 feet wide, right? And then, so here's my opposite side. And we know the angle of depression from where she stands to the bottom of the opposite side is 52 degrees. So that's telling us the line of sight is from the edge, right, where her feet are, to the bottom of the opposite side. So that's my line of sight. So what's tricky here is to remember the angle of depression goes from the horizontal down. A lot of people like to put it here with the vertical, but that's not where it goes. It's going to be the horizontal down. So this is 52 degrees. Remember, if you would like, that angle of depression corresponds to the angle of elevation. So this is also 52 degrees because we have a rectangle, basically, right? Because we can make a right angle, that vertical height of your crevice is going to be perpendicular to the ground here. So then it's kind of up to you what you want to do. So we want to know how deep the crevice is. So the depth is going to be, from top to bottom, that's x. So then we want to look at what we have and think about your SOHCAHTOA. So what do you think we're going to do? Well, hopefully we saw we're looking for the opposite side. We know the 115, which is the adjacent side. So opposite and adjacent should give me tangent. So tangent of 52 equals x over 115. And then we can go ahead and solve that. And there you go, making sure we round to the nearest foot, which is again the nearest ones position, 147 feet. Remember, it never hurts again to have the exact value. Okay, so the examples we did today don't include solving for the angle measure, but I could ask you to find the missing angle of elevation or the missing angle of depression. So make sure you're reading the directions carefully, labeling your diagrams, labeling your diagrams, and thinking about your SOHCAHTOA. So we'll do that last example tomorrow in class. Thanks for listening. Okay, so let's actually go through and finish off example 3. And with this problem, what's really important is how you actually draw the diagram. So we really want to make sure we know what's going on, and then of course look at the question, because not every question is going to be as straightforward as examples 1 and 2, or you're just finding a single distance. So let's actually read through the problem. In example 3, an observer in a lighthouse is 69 feet above the water. He sights 2 boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. What is the distance between the 2 boats? And let's round that answer to the nearest foot. So when you're looking at this first piece of information, the lighthouse is 69 feet above the water. So what we want to do is you can just use kind of a vertical segment if you'd like, but that's going to represent my lighthouse. And that lighthouse is 69 feet above the water. Okay, and then remember your observer looks straight out. So this is your line of sight, this horizontal line. And we have 2 boats in front of us. So we've got one boat here who's closer. So if this is the water, right? We've got one boat that's a little bit closer and one boat that's a little bit farther, right? So one boat is the nearest boat, right? We can look down and see it at an angle of depression of 48 degrees. Now remember, your angle of depression goes from your horizontal neutral down to what you're looking at. So that first angle of depression goes from the horizontal down, and that is 48 degrees. And then we've got a second boat that's farther away. So this second boat, we can look down and see it at an angle of depression of 22 degrees. And that makes sense because, right, the closer something is, the further down you're going to have to tilt your head so the angle becomes steeper from your neutral, like, straightforward position. Okay, so there's our depiction of the diagram. So what I want you guys to see is we have two triangles, because remember, unless otherwise noted, our vertical is going to be making a right angle. It's going to be perpendicular to the ground or the water or whatever we're working with, right? So we actually have two right triangles here, one with the nearer boat and one with the farther boat. So the last thing we want to do before we actually attack the problem is know what we're looking for. We want to find the distance between the two boats. So where is that distance between the two boats? Well, that's right here. So this is the x that I'm looking for. And that is not part of the right triangle. So then we have to think, wait, how do I even figure this out using the triangles in the diagram? Well, remember, we have kind of one triangle nested inside the other. So if we take this apart, right, and this is the nearer boat, this is 69 feet, and that angle is 48 degrees. We can look for this segment, which I'll call A, right? And that A is this corresponding piece. Now, if we look at the larger triangle going to the second boat, this is still 69 feet. This angle of depression is 22 degrees, and we can call this length B. Now, where is B? Well, B is this distance, all the way from the lighthouse to the second boat. So then now we have to just go back into our memory, back to, chapter 1, unit 1, use your segment addition postulate. X is equal to the difference of B minus A, because the two segments A and X together create B. So we want to use our trig to find A, to find B, and then do that subtraction. Okay, so that's the plan. Remember, every angle of elevation and angle of depression, corresponding angle of depression, are congruent because of your alternate interior angles theorem. So if that's 48, this is also 48. If that's 22, this is also 22. And then we'll notice, hey, I'm dealing with opposite, looking for adjacent for both of these triangles. So then I'm doing TOA, which is a tangent. So tangent 48 equals 69 over A. Tangent 22 equals 69 over B. You can cross multiply, right? Make this tangent 48 over 1, tangent 22 over 1. So we'll get A times tangent 48 equals 69. B times tangent 22 equals 69. Divide by your tangent. And then A equals 69 over tangent 48. Remember, we only want to round every answer once if possible. So I'm not going to round these two values of A and B. I'm going to go ahead and set this up and say, well, X is the difference of B, which is 69 divided by tangent 22, minus A, which is 69 divided by tangent 48. And I'm going to actually put that into my calculator. Now, of course, depending on whatever calculator you have, you may or may not have the option of doing all this in one line. I know my calculator can do it. But if yours cannot, then you do want to make sure you try not to round too much. So I might do 69 divided by tangent 22 first, and if my calculator can't do the subtraction, I might just take that and say, okay, that's about 170.78099929. So use a ton of decimal values, so that way you're not rounding that nearest foot too early, okay? But anyway, I'll write down what I see in my calculator. So this is, if I, again, didn't have a calculator, I can do it all in one. I would be doing 170.78099929, right? And that actually keeps going on forever. And then minus, and then 69 divided by tangent 48. And that'll be 62.1278796, and it goes on forever. So again, I'm using a ton of decimal values because I don't want to round that one place too much. So now we can go ahead and do that rounding. And then make sure you see the directions say to the nearest foot. So we're going to get approximately 109 feet. So every problem is going to be a little different. There could be, of course, other things. I've seen problems where it's asking you for a vertical distance, like how far a rocket has traveled and things like that. So please read the directions carefully, really look at how to draw your diagram. And that's it for angles of elevation and depression.